So I've noticed that I always start my videos with this very horrible-esque kind of like kind of, which I think is a New York accent for all right. So I'm going to go with a little more of a, in today's lesson, we will be working on improper integrals, something like that. So improper integrals, well, everybody's like, what the hell is an improper integral? If it's improper, what do you mean? How about e to the negative x squared? Why not? So, hey, can we find the integral from 0 to -2? Well, yeah, it's just area under the curve, piece of cake. What about from 0 to infinity? So this kind of thing. And it just goes on and on and on. And, you know, you're like, well, no, I mean, if we're adding up little bits and pieces out here forever, no. Well, it turns out we can. It doesn't make any sense, but we can. And it's very similar to, I'll go up here, what's 1 plus 1/2 plus 1/4 plus 1/8 plus ... It's like, we'll keep adding pieces out here, but they become so small, eventually we just round it up to 2. So that's what's going on down here. Although, sometimes you can't. Sometimes you are adding up chunks that are too big. This pretty much describes 90% of the problems people have with the next unit, infinite series. So we are giving you a taste now. A lot of people don't tie the two together. I try to, and this is actually an integral test that we get to use in unit 10, all right? So here's how we do it. We say, well, if we know we're gonna have a problem out here, infinity, we just call it b, and then say limit as b goes to infinity, which is the dumbest thing I've ever seen. Really, why not just say, well, that doesn't make any sense. Yeah, it's pretty lame, but. So these are improper integrals, all right? Maybe it's from 0 to 4 and there's an asymptote at 2. That would be an improper integral. So we have an asymptote. We'd have to break it up. Not indefinite integrals, which a lot of people have a problem. So integrals with infinite limits of integration, or could just be from number to number, but there's an infinite discontinuity. So for continuous, I just showed you, negative continuous, well, duh. And then if it's from negative infinity to infinity, we might have to break it up in the middle. All right. And see some number in there. Well, what do you want to use? You can use whatever you want. Doesn't really matter. Often it'll be 0, something like that. So yeah, like I just said, can we always find the limit of an improper integral? You're like, wow, that's a cool little technique. Now I can solve any problem I want. No, not always. All right. If we can't, we say that the integral diverges, right? So can't it diverges. You're going to learn to hate that expression. Just deal with it. I don't like my handwriting. Gotta get my glasses back on. I'm gonna make a real G. All right. So we cannot always find this. No. And you'll know, you'll do it just like we did before. We find the limit is infinity. Okay, we can't. All right. If we can, we say it converges. Better G, better R. Oh, I'm so happy. And it doesn't just converge, it converges to a number. Unit 10. Unit 10. Hey, I have a series. Does it sum up? Hey, well, let's do an integral test. Yep, integral works, therefore the series works. Yeah, we'll get there. So evaluate this one. E to the x. Definite integrals and evaluate the integral. So limit a approaches negative infinity. A to, hey, how about 0? Sure. E to the x dx plus limit as b approaches. And a lot of times they use b right off the bat. I don't know why. It just, who cares? It's just a letter. All right. So integral of e to the x, just e to the x, but we keep the limit thing. A approaches negative infinity. And we say e to the x from a to 0 plus limit a approach b approaches infinity from 0 to b e to the x. I've lost my mind. 0 to b. All right, we got problems changing color so we can see what's going on. And the problem is that we can't always do it. So now we actually plug in, like, well, then what was that for? No, just leave me alone, okay? E to the 0 minus e to the a, but I know that a is negative infinity, so I'm going to plug it in, negative infinity, plus e to the infinity minus e to the 0. Notice these will cancel out. This is negative 1 over infinity, really big number, plus e to the infinity, which is 0 plus e to the infinity, which is e to the infinity, which is infinity. How many times can I say infinity? Yeah, okay, it diverges. This is one of those times it doesn't work. And if you think about it, that was kind of a dumb moment. Although there is something to be learned in there. We could add up everything on this side. We can add up everything from here over. But here it just gets bigger and bigger, so that's where the divergence happens. So it's pretty rare you're going to see this negative infinity. It's more likely going to be a problem like this. Can we add up 1 over x? And I'm pretty confident the answer is no. And you might want to learn that now because you're going to need it in the next unit. And a lot of people disagree with me. So limit, and we use b usually. Now I'm using a, but you will see it as b. 1 to, oh, goodness gracious, a dx over x equals limit as a approaches infinity of ln of x from 1 to a, which is ln of infinity minus ln of 1. That's infinity, therefore it diverges. At which point you're like, why are you even bothering? All these problems diverge. I just want to show you what's coming. Okay, so make sure we're clear about that. So let's screw with you a little bit here. What about this? And you should be going, wait a minute, that means I have to integrate that. I don't want to integrate that. That looks horrible. Yeah, pretty much. So what's going on? Well, we're just practicing, making sure we remember how to do this stuff. 2 over x squared plus 4x plus 3 equals a over x plus 3 plus b over x plus 1. Yeah, let's just jump right to it. A times x plus 1 plus b times x plus 3 equals 2. X equals negative 1. B equals 1. X equals negative 3. A equals negative 1. Okay, so here we go. Change colors, see what we're doing. Limit b. Why b? Yeah, why not? From 0 to b of negative 1 over x plus 3 plus 1 over x plus 1 dx. Limit b approaches infinity. A lot of people throw this out. I'm not going to have a problem with it, but in the AP exam, they're going to want to see it. You might see this on the AP exam. It's pretty rare. I've seen it in the multiple choice questions where you can, who cares, you're getting an answer. In the free response, I've seen problems, but pretty tame compared to this. So negative ln of absolute value x plus 3 plus ln of absolute value x plus 1, 0 to b. Equals limit b approaches infinity ln x plus 1 over x plus 3 because of the minus here. Still got 0 to b. And now finally I'll throw it out. If I plug in infinity for b, I get infinity over infinity. Well, the powers dictate. I get ln of 1 minus ln of 1/3. That's 0 ln of 1/3 is the same as ln of 3. Don't know why. Go up the negative first, flip the exponent. Crazy, right? Good review, among other things. All right. Let's go with a this time. Why not? Limit as a approaches infinity, 1 to a, x e to the negative x dx. Holy cow. U equals x, du equals dx, dv equals e to the negative x dx, v equals negative e to the negative x. Does any of this make sense? I don't remember. Hopefully we can do this. So that means that the integral of x e to the negative x dx equals x negative e to the negative x minus, comes a positive because of this one right here, e to the negative x dx, which equals negative x e to the negative x minus e to the negative x. We'll see, but we don't need that. All right. Equals limit a approaches infinity, negative x e to the negative x minus e to the negative x 1 to a. Let's do the a part. Let's do it in blue. All right, a goes to infinity. We get x over negative infinity over e to the infinity minus 1 over e to the infinity. Right, you might say, well, we got a problem here, but I can L'Hopital's rule this as negative x over e to the x. I know the bottom's going to dominate. I'll get 0 here, and I'll get 0 here. So all of it drops out. I get 0. Let's do the b part. Negative 1 e to the negative 1 minus e to the negative 1 equals negative 2 over e, right? Yeah, negative 2 over e. Negative 1 minus 1, negative 2 all over e. Yeah, sure. Plug them together. 0 minus negative 2 over e equals 2 over e. Bet you weren't going to be doing something like that when you signed up for the course last April, February, or March. Challenging stuff. Okay. How about this one? And again, this is great practice, even though you hate it. It's not a bad thing. Limit as, oh, for goodness sakes, a approaches negative infinity, negative, no, a to 0. 1 plus x squared plus limit as b approaches infinity, 0 to b, dx over 1 plus x squared equals limit as a approaches negative infinity, arc tangent x, a to 0, plus limit as b approaches infinity, arc tangent x, 0 to b, equals, here we go, arctangent of 0 is 0. Arctangent of negative infinity is minus negative pi over 2 minus arctangent of infinity is pi over 2 this should be positive. We're adding these two things. Minus arctangent of 0, 0. Plus plus, we end up with pi. Oh, that's crazy. That's just certifiable. All right, what if there's a vertical asymptote in the integral? You know, an infinite discontinuity. All right, so hey, from 0 to 1, well, I know at 0 we have a problem. We can't, oh, it's 1 over square root of x. This is x to the negative 1/2. So we have to say, well, I can't plug in 0, so I have to go limit as a approaches 0, a to 1, x to the negative 1/2. Why do I do that? Dx. Limit a approaches 0, add 1/1/2 divided by 2x to the 1/2, a to 1. Okay, plug in 0, no problem. 0 minus 2. Have this backwards. Hate it when I do that. Equals top 2 times 1 minus 2 times 0 equals 2. That's cool. That's cool math. Maybe. All right, so what do we do in certain circumstances? Well, let's just tackle these rules one at a time. We just did one of them. All right, let's do another one. Here's an asymptote at 1, so we're going to break this into 2 pieces. All right, a little tight on space, but we'll work it out. Limit as a approaches 1, 0 to 1, x minus 1 to the negative 2/3 dx, plus limit b approaches 1, 1 to 3, x minus 1 to the negative 2/3 dx. Let's do the first piece in blue. Limit a approaches 1, add 1 1/3, multiply 3x minus 1 to the 1/3. This is wrong. A, very upsetting. B, yeah, well, what are you gonna do? 0 to A, which is 0 minus plug in 0, we get negative 1, so 1/3 is negative 1. That's the left part. Hope that didn't record. Still recording? Yep, still recording. One moment. I'll actually pause this. One of the fun parts about making videos, there's always something go wrong. Okay, plus limit b goes to 1, 3x minus 1 to the 1/3, b to 3 equals 3 times 3rd root of 2 minus 0. So that's it. So combined, we get 3 plus 3 times 3rd root of 2. Wow. Wow. That's all I can say. All right, let's hope we have enough space here. We have an asymptote at 2. So we're going to have to go, hey, let's go with C. We haven't done C yet. Okay, cool. Limit as C goes to 2. And we're coming from the left. So technically we should put a negative up there. If you don't, it's not going to be the end of the world. 1 to C, x minus 2 to the negative 1st dx, which I didn't have to do because it's just a natural log problem. Limit C approaches from the negative side, ln x minus 2, 1 to C, equals ln of C is 2 from the negative side. I don't know why I got that, just negative. 2 minus 2 is 0. Minus ln of absolute value of -1. Haha, the absolute value finally worked for a change, which is negative infinity minus 0, negative infinity diverges. Wow. Okay, let's see if we can't figure out how the arc length formula shows that the circumference is 4 pi. Well, I recall arc length formula is square root of 1 plus dy dx squared dx, integral. And in this case, it's going to be from 0 to 2. Looks like I left this one for my students. Integral from 0 to 2, y squared equals 4 minus x squared, y equals square root of 4 minus x squared, 4 minus x squared to the 1/2, dy dx. I need to think about this from 0 to 2. Square root of 4 minus x squared. I think that's this. Oh no, that would be plus minus, so it's not even that. It's just here, 0 to 2. Sure, whatever you say. So why do I need all this stuff? Because I think we're going to end up with an asymptote somewhere in there. 1/2 2x 4 minus x squared to the negative 1/2. So I can't put in 2. Can't put in 2. So we're going to have to fix that. And when we're done, we're going to multiply by 4. I'm not going to throw that in. It's just going to cause problems. 2, 2. So let's see what we got here. Limit x approaches 2. Integral 0 to 2. 1 plus x 4 minus x squared to the negative 1/2 squared dx. Wonder if I can do this mathematically. A approaches 2. 0 to a. Get sloppy here. Apologies. Square root of 1 plus x squared over 4 minus x squared. Dx. 4 minus x squared over 4 minus x squared. Might run out of space. We'll do the best we can. A over 2. Still haven't done any calc, just a lot of algebra. 4 minus x squared plus x squared by square root of 4 over 4 minus x squared dx. Nope, can't do that. I can get 2 out on top. I can't do that. Anyway, I put that in the calculator, I get pi. I won't do this one in class. It's a bad problem. All right, hope that's enough to keep you busy. Good luck.